Hello, welcome again. We are solving some questions of heat transfer. The topic is one-dimensional conduction with heat generation pins and unsteady heat flow. Question number 34 from GATE 2013 ME is a steel ball of diameter 60 mm is initially in thermal equilibrium at 1030 degrees Celsius in a furnace. It is suddenly removed from the furnace and cooled in ambient air at 30 degrees Celsius with convective heat transfer coefficient H is equal to 20 watt per meter square per degree Kelvin. The thermophysical properties of steel are density rho is equal to 7800 kilogram per meter cube, conductivity K is equal to 40 watt per meter per degree Kelvin, and specific heat C is equal to 600 joule per kilogram per degree Kelvin. The time required in second to cool steel ball in air from 1030 degree Celsius to 430 degree Celsius. Option A 519, option B 931, and option C 1195, option D 2144. Okay. So here given that the heat transfer coefficient of the medium is 20 watt per meter square. Okay, and diameter of ball is 60 mm. Okay, diameter of ball is 60 mm. And conductivity of steel ball is 40 watt per meter per degree. And specific heat of steel is Cp is equal to 600 joule per kilogram per degree, and density is 7800 kilogram per meter cube. And initial temperature of the ball is 103 degrees Celsius. And ambient air temperature, or we can say the convective medium temperature is 330 degrees Celsius. Okay. And now and final temperature of the ball is 430 degrees Celsius. Okay, initial temperature is 1030 and final temperature is 430, and environment temperature is 30 degrees Celsius. So as it is the case of unsteady flow, because we have to find out the time, and because heat transfer rate is different at different times, so we will find out Bayes number, and Bayes number is HL by K, where H is convective heat transfer coefficient of the medium and K is conductivity of the ball or steel or the metal which has to be cooled. Okay. And L is your characteristic length, that is volume by area. So volume of the ball is ball is sphere, so volume of ball is 4 by 3 pi r cube, and surface area is 4 pi r square. So it will be your 4 cancel out, it will be r by 3, okay, or 30 by 3, or we can say r is diameter is 60 mm, so r is 30. So it is so L is your 10 mm, or we can in meter it is 0.01 meter, and convective heat transfer coefficient is given as 20, and conductivity of the steel ball is given as 40. So Bayes number comes out as 0.005, which is less than 0.1, so we can apply lump parameter. So to apply lump parameter, we need another number, that is Fodder number, and Fodder number is F naught alpha by L square into tau, where alpha is thermal diffusivity and tau is time, and L is again this characteristic that we have found out by 10 or 0.01 meter. Now now we have to find out alpha. Alpha is thermal diffusivity, and it is K by rho Cp. K is given, rho is given, rho is density, K is conductivity, and Cp is given. So it is here 8.47 into minus 6. Okay, now if we put here, okay, if we put the value of alpha here, okay, then and put the value of L here, that is 0.01 meter. Okay, so we can find out Fourier number in terms of tau. Okay, now we have Bayes number, we have Fourier number. Now according to lump parameter, instantaneous temperature is given as we can find out instantaneous temperature. So according to lump parameter, that the formula is T minus Ca divided by Ti minus Ca, where T is instantaneous temperature, or we can say the temperature at time tau. If we put here byte number and serial number in terms of tau. Okay. And TA is your ambient temperature, Ti is your initial temperature. Okay, so temperature after time tau is your because you have to find out time tau when the temperature 430 is reached. So T is your 430 and TA is ambient temperature 30 and Ti is your initial temperature 1030. Okay, now and Barrett number is your 0.005 and Fourier number in terms of tau is this value is 0.8547 tau. Okay. So now we can solve it taking log both sides. So we can find out tau as 2144 seconds. So answer is 2144 seconds, option D.